For part 2, we're going to take a look at some golf example. We're hitting a ball with a 7-iron. It leaves the club with the initial velocity of 110 feet per second. And when a ball leaves any type of club, depending on the club, it leaves at a different angle. A 7-iron typically has about 35 degrees. So here's the angle of our club. So there's our theta, with the horizontal, of course. Now, the first thing I'm going to do is I'm going to write our equation, our parametric for this one. So this is kind of fun. And I got some space here. X equals, easy breezy, 110 cosine of 35 degrees t. Y equals, now my initial height doesn't say, assume it's 0, plus 110 sine of 35 degrees t minus 16t squared. And I'm going to go ahead and sketch it. Go to y equals. Now I'm going to clear out our record, clear out everything that's in there. Clear. Type in my equation, 110 cosine 35t. Enter 110 sine 35t minus 16t squared. And if I graph this, hopefully this will be to work. Oh, there it is. That's plenty of space. We actually get the path that the ball makes. Now, if you go to window, play around with the T max and T step sometimes. This slows it down, speeds it up. This will, of course, change your time. Like if I only went for 3 seconds. Like for 3 seconds, if you notice, the ball never lands. So in 3 seconds, that's actually telling me the ball is still in the air. So, So if I go to my window, change that to 8 seconds, and that gives me plenty of time because I can actually see it cross. Now, I want to find the maximum distance that the ball will travel. Now, earlier we used the maximum distance from the maximum height, but there's another way we can get the maximum distance that the ball will travel, and it's really not all that hard to do. To get the maximum distance, we have to set our y value equal to 0. That's going to solve for t here. Now, that's going to change the way we have to solve this, though, from the graph. So if I set this equation equal to 0, I'm going to solve for t. Now, hard to do this by hand, but we can use a calculator to answer this, okay? So what I'm going to do is, because I'm not using my parametric, I'm only using the y, I actually have to go back to my y function. My mode. I have to actually switch to function mode. So we're going to switch to function mode. Okay? So go to function, hit enter, and I'm going to go to y equals, clear out what's in there, 110 sine 35 t minus 16 t squared. Whoops, delete. And I'm going to graph this. I don't know what it looks like. Let's see. Oh, definitely change my window maybe. My window. Oh, it only goes 500, so let me go zoom 6. Let me just go zoom 6. There it is. Now, I really don't care what the graph looks like. I'm only using it to get where it crosses the x-axis. And that's right about here. So I go second calc, second calc, 0. It looks to be between maybe 4 and 6. Hit enter. No sign change. I missed it. Second calc, 0, 1. Oh, should be between 3 and 6. Now try it. There we go, 3.94. I missed it the first time. So it's at 3.943 seconds. Okay? Now, to get the maximum distance, I'm going to use my x equation. 110 cosine 35t, and I'm just going to plug in my answer. 110 cosine 35, and this will tell me how far the ball traveled. Let's see if we made a hole in one. Second quit, just like I go 110 cosine 35 times 3.943. I hit enter and the ball traveled 355.291 feet. And that's how far the ball traveled in the air. Mine always rely on the bouncing and everything like that. Okay? Very good. Now, the next question says, well, what's the maximum height of the ball? Well, this is the great thing. If you're already in function mode, go to graph. In between here, it tells me the maximum height. So I can't really see it, but I know it lies between here and here. Between x equals 0, t equals 0, and t equals 3.943. So second calc, all I gotta do is go for here. Second calc, maximum. Go to my maximum. It looks like between 0 and my 3.943. I hit enter, and it gives me my height. It occurs at t equals 1.972 seconds and a height of 62.1996 feet. So about 62.2 feet. That's the maximum height of the ball. Very good. All right, so let's take a look at C. Now C is just like the last question. 2C. A 4-foot pole is standing in the direction of a golf ball 320 feet down the range. Will the ball go over the pole? So what do we have to? We already know the ball travels 355 feet. So we have to go back to parametrics. Go back to parametric mode. So, and I'm going to let my x2 equal 320 and my y2 equal 4. And I'm going to look at that. Okay, let's take a look here. Go back to mode. Go back to parametric. Y equals, there's my 320. And there's 4. And I'm going to look for the dot. Look for the dot. Look for the dot. And graph it. Whoa, got to change my window. Doggone it. Window. Okay. We had to go a lot further than that. We had to go what? Well, we already know it traveled 355 feet, so let's go 400, right? Whoa, delete. And my Y max is easy now because my Y max was 62. I can make that just 70. And now if I graph it, there it is. Look for the dot. Where's the dot? There it is. There's the dot. Everybody see the dot? Right there, near the x-axis. That's the dot. That's the path of the ball. We cleared the hole. So look for the dot. Yes. It will clear. So, because y, the path of ball, is greater than the height, that's greater than the height of the pole at 320 feet. There we go. All right, so what I want you guys to try is number 4. See if we can just set this one up here, and we'll go over this one tomorrow in class, okay? Bye.